Hi everyone, welcome back to Made Everything Official. From raw plastic to crystal clear bottled water, this is the complete journey of modern beverage production by King Machine Company, a global expert in PET packaging and filling technology. NNTHE process begins with preforms and caps created from PET and PE resins through precision injection molding. These tiny preforms, once heated and stretched inside a blow molding machine, are transformed into perfectly shaped bottles. Supported by a water chiller and compressed air system, each bottle is formed with accuracy and durability. Next, air conveyors guide the empty bottles to the heart of the factory, the rinse, fill, and seal unit. Inside this integrated machine, bottles are first rinsed with ozone-treated water to ensure purity. Then, high-speed filling nozzles deliver water with exceptional precision, maintaining hygiene and consistency. Finally, the sealing heads close each bottle tightly, protecting freshness and preventing contamination. Once sealed, bottles move through quality inspection, where any impurities are detected by eye and by automated sensors. Then comes the labeling stage. King Machine offers multiple solutions, from OPP and PVC shrink labeling to adhesive label systems, each customizable to brand needs. NNTHE finished bottles are date-coated, shrink-wrapped, or packed into cartons before being palletized and shipped to markets worldwide. Each line is designed for reliability, efficiency, and minimal downtime, capable of producing thousands of bottles per hour. King Machine has supplied over 1,000 complete water filling lines across 90 countries, serving trusted brands from Europe to Africa and Asia. With a strong commitment to innovation, sustainability, and global service, they continue to lead the future of smart beverage production. From a simple flat sheet of metal to a flawlessly finished can, this is a journey of transformation, precision, and engineering mastery. And inside the plant, the process begins with edge milling, where raw steel plates are carefully trimmed and squared. This ensures perfectly clean edges for forming and eliminates even the smallest imperfections that could affect later welding. The gleaming sheets emerge uniform, ready to take shape. Next comes the three-roll forming stage, where the flat sheet passes between synchronized rollers that gradually bend it into a smooth, seamless cylinder. The force applied here is immense, but meticulously controlled. Pressure, rotation speed, and curvature, all calibrated to the millimeter. It's here that raw material begins to gain structure, the first sign of the can it will become. And in post-bending, the edges are realigned with microscopic precision. Robots and sensors ensure the two sides of the cylinder meet perfectly, forming a tight seam with zero gap. This alignment is critical. A single millimeter's deviation could compromise the can's integrity under pressure or during filling. Formed body then advances to tack welding, where small preliminary welds are applied. These tiny fusions serve as anchors, holding the cylinder securely in shape before the full weld is performed. Inside the internal welding machine, a continuous arc runs through the seam from end to end, fusing the metal along its inner surface. The heat is intense, melting and reforming steel into a solid, uniform bond. Immediately after, the external welding machine reinforces that seam from the outside, smoothing the joint and ensuring double-layered durability. Now, every can passes through a stage of visual inspection. Automated cameras, supported by trained inspectors, scan for weld flaws, uneven edges, and distortions in shape. Only those that meet the standard continue forward. Next stop is the expander, where hydraulic arms or rollers carefully stretch the can from the inside to achieve the exact required diameter. This ensures consistent dimensions across thousands of units, vital for downstream operations like sealing and labeling. Following expansion comes post-washing, a high-pressure cleaning system that removes oil, oxide, and welding residue. The clean, polished surface now reflects light, but more importantly, it prepares the can for strict non-destructive testing. In the ultrasonic inspection stage, invisible sound waves penetrate the welded seam, searching for microscopic cracks or air gaps. The system can detect flaws smaller than a human hair, ensuring each weld is structurally perfect. Next, real-time X-ray inspection provides a deeper look, scanning each can's wall thickness, seam depth, and internal alignment. Every data point is logged automatically, forming part of a digital quality record. And after passing these demanding tests, cans move to end beveling, where their open edges are smoothly tapered. This step allows precise fitting of lids or joining to other components while preventing sharp edges that could cause defects or injury. NTHE beveled ends are then polished, ensuring a uniform look and a clean seal interface. Finally comes the final inspection, a rigorous review that combines measurement, strength testing, and visual grading. Each can must meet strict dimensional tolerances, mechanical strength requirements, and surface quality standards before it earns approval. From raw steel to shining product, every step in this process is a dance between heat, pressure, and precision. Machines work in harmony with sensors and human expertise to create something deceptively simple. A metal can strong enough to hold pressure, pure enough to store food, and precise enough for industrial use. Behind each can lies a world of engineering innovation, automation, and craftsmanship, proof that even the simplest objects can embody extraordinary technology. Metal can production is a precise, multi-stage journey, where raw steel is shaped, welded, and refined into containers ready to protect food, beverages, and more. Today, you'll see each step: edge milling, bending, welding, inspection, and finishing. All choreographed in high-throughput NNTHE process begins with edge milling. Sharp cutting tools trim the steel blanks, removing rough edges and creating perfect starting surfaces. This ensures the subsequent bending and welding will align cleanly. Next, the blank enters the 3-roll machine. Here, the metal is gradually bent along its length. 3 rollers apply forming forces to curve the strip into a cylindrical shape. This controlled bending means minimal stress and more uniform walls. Each formed blank is handed off to a tack welding machine, where short welds along the seam hold the cylinder together before final welding. This temporary join keeps alignment before the full weld passes. Then comes internal welding, performed by the internal welding MC. The seam is fused from the inside, ensuring deep penetration and metallurgical continuity. After that, the external welding MC reinforces the seam from the outside, adding strength and surface finish. And every welded can undergo visual inspection, where cameras and operators check for surface defects, gaps, or misalignment. Then it proceeds to the expander stage, where internal rollers expand the can slightly to standard diameter and roundness. After expansion, the can moves through the post-washing MC, cleaning away residues, oils, or debris to prep for quality testing. Next, ultrasonic welding detection scans seams for internal flaws, rejecting any unit with hidden defects. NNSI simultaneously, an X-ray real-time machine inspects internal structure, seam continuity, and wall thickness. Only cans passing these non-destructive checks move on to end beveling MC, where the open end is shaped with precise chamfers to prepare for lids or closures. Finally, before packing, every can undergoes final inspection, dimensional checks, finish verification, leak testing, and a final surface check. Only those meeting all specifications are approved for delivery. From flat blank to finished metal can, each stage, milling, rolling, bending, welding, inspection, works in harmony to produce containers that are strong, precise, and ready for any product they will protect. Introducing the next generation of rebar, GFRP glass fiber reinforced polymer, engineered for strength, durability, and corrosion resistance. In this facility, raw fibers are pulled and impregnated with resin, then shaped through precision pultrusion. The result: a composite bar with exceptional tensile strength. NNTO enhanced bonding with concrete. The rebar passes through a sand coating station. Fine sand adheres to the surface, creating micro-texture that ensures strong mechanical grip inside structures. In each bar is exposed, controlled UV curing and calibrated tensioning, guaranteeing consistent dimensions and stability. The process is continuous, automated, and designed for high throughput. This equipment is ideal for modern infrastructure, offering long-term performance without rust, high electrical insulation, and a fraction of the weight of steel. This is where insulation meets structure. The production line for PER and PIR sandwich panels, creating rigid composite panels that deliver thermal performance and structural strength. NNTHE process begins with material preparation. Outer facings, usually coated steel or aluminum sheets, are fed into the line. At the same time, the core materials polyurethane PR or polyisocyanurate PIR foam precursors are precisely metered. Next comes foaming and bonding. The foam mixture is injected between the two outer skins, where it expands and bonds to both facings, forming a solid core layer. In the case of PIR, higher temperatures and carefully controlled formulation provide better fire resistance and stability. And once foamed, the panel is formed and trimmed. Rollers and cutting stages shape the edges and remove excess foam, ensuring uniform dimensions. Pressing and curing then bake the panel under heat and pressure so the core fully bonds to the surfaces and the structure becomes rigid. Throughout this line, continuous production ensures efficiency. Panels move from one station to the next seamlessly, with synchronized control of temperature, pressure, foam rates, and conveyor speed. And quality control is constant. Thickness, bonding integrity, Flatness, density, and fire rating are tested at stages. Only those meeting strict specifications proceed. NNBY the end. The finished panels emerge, ready for facades, roofs, cold storage, and high-performance buildings. And inside the factory, each steel door begins its journey as raw metal sheets, transformed through advanced welded construction. Unlike riveted or bonded doors, this method gives unmatched structural integrity and long-term durability, ensuring every door is built to perform under pressure. And every model features expandable sides as standard, offering up to 18 millimeters of flexibility on each side of the frame. This innovation simplifies installation while maintaining a perfect fit, even in the most demanding environments. NNTO maximize rigidity. Strongdor uses a Dutch fold interlock design, a unique method that locks both skins of the leaf together, forming one cohesive structure. This technique prevents loosening over time, outperforming traditional riveted doors that can weaken after years of use. In the modern beverage industry, speed, precision, and hygiene define excellence. This is a 20,000 bottles per hour CSD production line, where every stage, from empty glass to perfectly sealed drink, operates in perfect synchronization. NNTHE process begins at the bottle infeed section. Empty glass bottles arrive through an automated conveyor system, guided and aligned with remarkable accuracy. Here, the bottles pass through the inspection unit, where optical sensors and air jets detect any imperfections, cracked necks, irregular rims, or contamination, ensuring only flawless bottles continue forward. They then enter the washing module, the first critical stage of preparation. Inside a fully enclosed stainless steel chamber, multiple nozzles spray jets of ozonated water and sterilizing solution. Each bottle is inverted and rinsed repeatedly to eliminate any residue or dust from transport. The system uses high-temperature rinsing, followed by purified water, guaranteeing hygiene that meets international food-grade standards. After washing, compressed sterile air removes any remaining moisture before the bottles move on. Next, the bottles reach the filling carousel, where precision engineering takes center stage. The filling process operates under isobaric pressure control, allowing carbonated beverages to flow smoothly into each bottle without foaming or loss of carbonation. Each filling valve is synchronized to the bottle's motion, ensuring exact volume, minimal spillage, and consistent quality. The stainless steel manifold, pressure regulators, and flow sensors keep every cycle stable and efficient. Once filled, bottles transfer seamlessly to the capping unit. Caps are automatically fed from a vibration hopper and positioned above the neck. Servo-driven heads descend to apply uniform torque, securing every closure to perfection. The system monitors cap presence and seal tightness in real time. Each rotation of the carousel locks in freshness and carbonation, a vital step that transforms a simple bottle into a ready-to-serve beverage. Beyond capping, the line continues with inspection and quality control. Vision systems check fill levels, label alignment, and closure integrity. Bottles that don't meet standards are automatically rejected and rerouted for further examination. Every acceptable bottle continues toward labeling and packaging, passing smoothly along anti-vibration conveyors designed to protect glass integrity. NNTHE labeling module can integrate various technologies: PVC shrink sleeves, self-adhesive labels, or OPP wraparound depending on product needs. Each label is applied precisely in its designated position, reflecting both brand identity and traceability. Immediately after labeling, date coding and batch printing ensure full compliance with traceability and export requirements. And at the downstream end, the packaging and palletizing section takes over. Bottles are grouped, shrink-wrapped, or packed into cartons. Robotic arms and servo conveyors arrange the packs with high precision, ready for warehousing and distribution. The entire process is fully automated, designed to reduce labor, eliminate contamination risks, and maintain continuous output. And central to the operation is an advanced PLC-controlled monitoring system. Real-time data from sensors, flow meters, and temperature probes feed into an intelligent interface, allowing operators to oversee every part of the process. This control system automatically adjusts parameters: filling speed, capping torque, rinsing time, ensuring the entire line runs with consistent accuracy and minimal waste. Every component of this 4-in-1 system, washing, filling, capping, and packaging, has been engineered for efficiency, energy savings, and long-term reliability. Stainless steel construction ensures durability and easy sanitation. Modular design allows flexible adaptation to different bottle shapes, volumes, and beverage types, from sparkling water to soft drinks or flavored tonics. Finally, the finished bottles glide out of the line, crystal clear, precisely filled, hermetically sealed, and ready to delight consumers around the world. This is the perfect fusion of automation, precision, and hygiene, where technology transforms simplicity into perfection. At 20,000 bottles per hour, this isn't just a production line. It's a symbol of modern beverage engineering, built to deliver quality, consistency, and speed at every stage. From washing to filling, from sealing to shipment. This is how the world's finest beverages come to life.